questions about? Three. Any other? Julia? Two. 2 and 3. Okay, so for number 2, we have to combine the terms, distribute the things on the outside, be careful with your negatives. So we have 12x plus 8 plus 10 minus 2x after you distribute both things. And then combine your like terms, your x's together, so 12x minus 2x would give us 10x. And then add your constants together, so plus 8.
Oh.
So there was no solving to get x by itself or anything like that because it wasn't an equation. So that was your final answer. Questions on that one? Number 3, you are evaluating. This -3 is where x is, so you're going to put -3 in for all of your x's. And simplify. So this will give us 9 minus 6. So f of -3 equals 3. Or you can write it as f of x equals 3. Questions on that one? Or other questions on the shortcut? If you do not have your calculator, go ahead and go grab that because you'll need that for today's lesson.
What is this unit called?
Transformational.
Which one is yours?
Eva, Aubrey, you don't have calculators. Eva, calculator. Everyone should have notes that look like this in front of them. This is the last lesson of this unit, which means your quiz and your tests are coming up. Quiz is Monday, test is next Wednesday.
Wait, that's the unit test, right?
Yes.
Oh.
This coming Wednesday or next class will be your flex review day, and then quiz test the following days. So the last thing we have to talk about in this unit is how to take equations and graph your absolute and quadratic functions. We are going to talk about 2 different ways. One using your transformations, and then one using your calculator to either check it or use your calculator in general.
We can use the calculator on the test.
Correct. For these, you'll need to know what type of function you have for each one. So whether it has an absolute value bar, so absolute value, or the square, so the quadratic. So for this first one, we know this is going to be absolute value because it has the bars. That means it's going to be shaped like a V, not a U. So G tells your laptop. Maya tells your laptop. Nikita tells your laptop. Okay. For each of these, we're going to start by graphing the vertex. Looking at the inside number and the outside number. The inside number is going to be opposite of whatever it says. So instead of -1, it would be +1. Outside number will be whatever it says. You are writing this down? And we're going to graph at 1, 2. That point. This next piece is not like a necessary step, but if it helps you see what we did, what happened, you could do that. So because this is over to the right, that was some horizontal shift. Right 1. And because this went up 2, that's some vertical shift. Up 2. And there aren't any other transformations that happen. There aren't any stretches or compressions or reflections. So that's the only thing that happened in this one. So then we can graph it based on what the parent function looks like. So you have to remember what that looks like. We start at the vertex. We're going to go up 1, right 1 as many times as possible.
Do we draw the original?
You don't have to. You can if it helps you see it. And then from the vertex, up 1, left 1 as many times as possible. You need at least 5 points. So you don't have to have all of these. Have to have 5, can have more than 5, cannot have less than 5.
Bless you.
Bless. We are going to do this in the calculator, but before that, do we have any questions on how we graph that?
So that's it.
Really, the only thing you would be checked for is, did you write your vertex? Is it correct? Did you graph your graph correctly? So in your calculator, reset it first, second plus 712. Except I'm drawing. Second plus 712. There we go. And in your y equals, you're going to type in that function.
I think the absolute.
Alpha window will give you the absolute value bars. So ADS, that one, choose that one. And then put in the rest of your function, x minus 1 on the inside, plus 2 on the outside. Alpha window, and then ADS. Once you have that in, go into your table, second graph. We said our vertex was at 1, 2. So I scrolled up a little bit. Then I can just match my other points. So if I start at 1, 2, my other points should be 0, 3, and 2, 3. 0, 3, 2, 3. Negative 2, 5. Sorry, I skipped 1. Negative 1, 4, and 3, 4. Negative 1, 4, 3, 4. And then so on and so forth. As long as your points match, then you did good. So for all of these problems, you could use your calculator for every single one as long as you graph it and write the vertex. Or you could find the vertex, graph it based on your transformations, and then double check it. I would say if you're using the transformations, the vertex and the transformations, I would highly recommend that you check it in your calculator. That way you know you graphed it correctly. Do we have any questions on number 1? Let's move on to 2. So this one does not have the bars, it has the square, so this is your x squared, or your quadratic function. What would the vertex of this one be?
Negative.
Yes,
wait.
negative.
There's 0,
But not
0, negative 3.
So this this always goes first.
Oh no,
inside.
negative 3, 0.
Correct. There's nothing on the outside, so anytime you don't see a number, put 0.
So that 2 has nothing to do with.
Has nothing to do with the vertex. We are going to use it though. So let's plot this point, negative 3, 0. That means it didn't move vertically, but it did shift to the left. What else happened? What other transformation happened? What did that 2 do?
Doesn't it flip it?
If there was a negative,
It goes up. Doesn't it?
doesn't shift because there's nothing in the back.
A stretch? No.
It is a stretch. It's a vertical
Horizontal.
stretch. It's a vertical stretch
Oh.
by 2. So that's going to help us plot the points. So your original, and you could graph that to find your original. Your original, you would go right 1, left 1, right 1 and up 1, and left 1 and up 1. But your y values are being stretched vertically, so instead of going up 1, you're going to go up 2. So to the right 1, up 2. To the left 1, up 2. Bless you. Then on your parent function, you usually go to the right 2 and up 4, and to the left 2 and up 4. That 4 is now being multiplied by 2, so now it's going up 8. So from the vertex, right 2 up 8 is going to be off the graph. And from the vertex, left 2 and up 8, again off the graph. It looks something like that. So right 1 up 2, left 1 up 2. So we can see it's vertically stretching or stretching towards the y-axis. Okay. Let's graph that one in the calculator just so we can make sure we did that correctly. So go into your y equals, clear that out, and then type in 2 parentheses x plus 3 parentheses with square on the outside. And then go into your table, second graph. We said our vertex was at negative 3, 0. So this should be at negative 4, 2, and negative 2, 2. Negative 4, 2, negative 2, 2. And negative 5, 8, and negative 1. 5, 8, and negative 1. They match. So even if you graph it incorrectly by hand, you could always check yourself and change it. Or you can use your calculator to start and then not have those issues.
And this is just it, right? Okay. I think I've just gotten slowly paranoid for each lesson because this seems way too simple.
That's good. That means you recognize the transformations enough that this makes sense.
I hope.
Okay. Number 3. What would your vertex be for number 3?
0, 4?
Yes. 0, negative 4, sorry.
Oh, it doesn't switch.
For the second number, no. For the first number, yes, if it's not 0. So start there. At 0, negative 4. So that would mean we don't have any horizontal shifts, but we did have a vertical shift, down 4. transformation occurred?
There's no reflection.
There is a reflection because of the negative. So because of that, that means instead of facing up, it's going to face down. There weren't any stretches or compressions, so the slope is the same. Instead of going up one, right one, we're going to go down one, left one, as many times as possible. Its absolute value starts to look like a V. And then from the vertex, down one, left one, as many times as possible. And connect your points. Questions on how we graph that before we double check it in the calculator? So in your y equals, go ahead and type in, or clear this out, type in a negative, then alpha window, your absolute value, only x on the inside, and then minus 4. It's very important that you put in the correct symbols. And then look at your table, second graph. We started at 0, -4, so the rest of these points should match. -1, -5, and 1, -5. -2, -6, and 2, -6. And we could check the others, but we really just needed 5 points, and that was 5. Questions on that one? What is our vertex for number 4? Yes.
Oh. And since it's squared, we know it's going to be.
A U shape, yep.
So there's no, what is it? So there's no stretch or, is compression?
Compression is the opposite, yes, and there's none of that
So
here either. And there's not a reflection. There aren't any horizontal shifts. So just vertical shift up 1 is the only thing that's going to happen. So then from this, go right 1, up 1. Left 1, up 1. This I would try to remember, or again, use your calculator to graph. And then usually it goes right 2, up 4. So from the vertex, right 2, go up 4. From the vertex, left 2, up 4. Just like that. So let's graph this in the calculator just to make sure we graph this correctly. So x squared plus 1. Look at your table, second graph. And then our vertex was 0, 1, so we should have -1, 2, and 1, 2. 1, 2, 1, 2, and -2, 5, 2, 5. -5. So that match. Okay. Questions so far? We're going to do 2 more and then you'll have time to practice.
Okay. This is what we're doing? Oh.
Because really the practice is, you'll need it to practice. Right, vertex for number 5.
Would be
Backwards, but not -3.
positive 3
+3.
and 0.
0. There we go. So that means we would have a horizontal shift to the right. and no vertical shifts. What else happened? Vertical. Vertical.
Vertical compression by half.
There we go. Vertical compression by half. What's nice about the absolute value is you just look at that number and that becomes your slope. So instead of up 1, right 1, you're now going up 1, right 2, and up 1, left 2. You could keep going left, but I would say make it even, so wherever you stop on the right, stop on the left. So it'll look just like that. Let's double check it in the calculator, make sure we graph it correctly. So alpha y equals to get your fraction. And then alpha window to get the absolute value. X minus 3. And then if I go into the graph, or the table, second graph, our vertex was at 3, 0. So we should have 1, 1, and 5, 1 as points. 1, 1, 5, 1. And negative 1, 2, and 7, 2 as points. And then what questions do we have on this one? And then last one. What would your vertex of this be?
0.
It is 0, 0, yes. So it means there aren't any horizontal or vertical shifts. What did happen? What did change? Yes, a vertical reflection. So it means instead of it facing up, it's going to face down. But the parent function values are going to be the same. Instead of going right 1, up 1, we're going to go right 1, down 1. And left 1, down 1. And then instead of going right 2, up 4, we're going to go down 4. And left 2, down 4. So last thing, let's check this in the calculator, make sure we graphed it correctly. Put in negative x squared, go into the table. We started at 0, 0. We have negative 1, negative 1, 1, negative 1, and those match. And negative 2, negative 4, and 2, negative 4, and those also match. Do we have any questions in general or specifically on how to graph absolute value and quadratics using the transformations or in your calculator?
For the test, right, would we put, like, if we graph it on our calculator, would we just say use chart, like for the previous unit?
The only thing I need to see is the vertex and the graph. So you write this and you graph this.
Oh.
Whether you did it in the calculator or using the transformations is your choice. Anything else? So you have different options on how to practice. The 2 Khan Academy quizzes that opened up today that are due Friday are on this, graphing absolute value and graphing quadratics and vertex forms. They're on the back of these notes, the very back page, has review on objective 3, 4, and 5. So 5 is this. So it's just another set of problems like this. But then 3 and 4, as well as other practice problems in these as well for just graphing. On Wednesday, you'll get an actual review on all of the objectives. So you can be working on this practice, Khan Academy that's due this week, Khan Academy from previous, any of those. Use this time wisely. Let me know if you have any questions.